Let's have a look at the next question. Here we have a question related to dynamics. Answer all three questions. The suggested time is about 15 minutes. We'll skip the directions for now. In an experiment, a student wishes to use a spring to accelerate a cart along a horizontal level track. The spring is attached to the left end of the track as shown in the figure above, produces a non-linear restoring force of magnitude Fs is equal to ax square as square plus bs, where s is the distance along the spring is compressed in meters. A measuring tape marked in centimeters is attached to the side of the track. The student places 5 photo gates on the track at the locations shown. A photo gate is a device which measures the time instant, or which records the time instant at which a particular object passes through the given photo gate. Derive an expression for the potential energy U as a function of compression S. Explain your answer or express your answer in terms of A, B, S, and any other fundamental constants. Here, we note the potential energy stored. I'm sorry, let me go back. Here we notice that the potential energy stored is a function of the restoring force F. In fact, the potential energy is the integral of the restoring force Fs, which is integrated with respect to x, where x is the displacement. Here, since s is a displacement, we could also resort to writing ds instead of dx. The limits are obviously 0 to s, which do not have to be applied because we're already integrating with respect to s. So this means integral of a s square plus b into s whole under ds. Integral of x power n is x power n plus 1 by n plus 1. So using the same, you get u is equal to a into s cube by 3 plus b into s square by 2. Now, moving on to the next part. In the preliminary experiment, the student pushes the cart of mass. So here the mass of the cart is given 0.3 kilogram. Compress the spring 0.04 meter. For this spring, so value of S is also given here as 0.04 meter. For this spring, the constant A is 200 Newton per meter square. The constant B is 150 Newton per meter. The cart is released from rest. Assume friction are negligible, which means there is no loss of energy. If there is no loss of energy, that means the potential energy is converted into the potential energy stored in the spring is converted into kinetic energy half mv square. The substitutions for m is 0.3, s is 0.04, a is 200, b is 150. Rewriting the equation in terms of v, we get 2 times of a into s cube by 3 plus b times s square by 2 whole divided by m, and this entire expression is under a square root. Simplifying, we get the value of v to be approximately 0.91 meter per second. Now we are also asked to find out the impulse. Impulse is nothing but the change in momentum delta p, which is momentum final minus momentum initial. Momentum final is mass 0.3 into final velocity 0.91 minus mass is initial is 0.3, whereas velocity initial is 0, giving us the impulse as 0.27 kg meter per second. In a second experiment, student collects the data using the photo gates. Each photo gate measures the speed of the cart as it passes through the gate. The student calculates a spring compression that should give the cart a speed of 0.32 meter per second after the cart loses contact with the spring. The student runs the experiment by pushing the cart into the spring, compressing the spring, and then thus converting the compressed elastic potential energy in the spring into the kinetic energy of the cart. Now, The speeds are measured with a precision of plus or minus 0.2 meters per second. The positions are measured with a precision of plus or minus 0.005 meter. So here the uncertainties are also given. Now, if on an axis given below, plot the data points for speed v of the cart as a function, speed v as a function of position x. Clearly scale and label all the axes as appropriate. So photo gate position, we'll take as 0.2, 0.4, 0.6, 0.8, and 1. So speed is approximately 0.412, 0.407, 0.399, 0.374, 0.388. So this is how we approximately get the graph. Compare the speed of the cart measured by photo gate 1 to the predicted value of the speed of the cart just after it loses contact with the spring. Just after it loses contact with the spring, we have found out it to be 0.91, whereas the actual value captured is 0.412. We understand that the predicted value is greater than the value measured at the photo gate because there could be errors related to the imperfection or the track not being a level track, but instead having a slope where acceleration due to gravity comes into the picture. So this could lead to an inconsistency between the predicted and the measured values. Moving on to part 2. From the measured speed values of the cart as it rolls down the track, give a physical explanation for any trend you observe. We understand that the velocity keeps on decreasing, which is an indication that while there is no friction between the cart and the surface, at least in the interval provided, there could be friction within the axles. The slope of the track could be also another factor for the trend of decreasing velocity or deceleration that we observe. So this concludes the solution to our question.